All right, polynomial 6.1 to 6.4 quiz review. Let's get right after it. So number 1 says rewrite each polynomial in standard form. So that means we have to put them in order from largest degree down to smallest degree. And then we got to do lead coefficient, the degree, the number of terms, name it, all that good stuff. So here we go. So the term with the highest power is right there. So that's 5x to the third. We then do our x squareds, which we have one of them. We then do our x to the firsts, and then we do our constant. So right now my numbers are in descending order, 3, 2, 1, 0. The lead coefficient is going to be this 5. The degree of the polynomial is the biggest degree, the highest one. So this polynomial is degree 3, with 3 e's there it looks like. The number of terms, well, we have 1, 2, 3, 4 terms. All right. And how do we name this? Well, we name it by its degree. So since we have a degree 3, this is going to be a cubic polynomial because that's the largest power. All right, next one, my biggest power is 4, so 2x to the fourth. We then flow into the x to the thirds. There are no x squareds. There is an x, and there are no constants. So the lead coefficient is 2. The degree of the polynomial is 4, which that will help me name it because it's a 4th degree polynomial. It is called a quartic. And the number of terms is 1, 2, 3 terms. All right. So, not something you'd probably see on the SAT, but there's some basics to kind of get our vocabulary down, all that type of good stuff. Moving right along, this is something you would see on standardized tests. So addition and subtraction, write your answer in descending order or standard form. So running through, you could stack these vertically on top of each other. I'm just going to go, 1x cubed plus 5x cubed, so that's 6 of them. That's the largest one, so those are gone. Now we got to deal with the x squareds. So I have 11 plus 4 more. It's going to give me 15 x squareds. So they're gone. All right, sorry about that little interruption. Then I have 0 x's over here plus a negative 2x over there, so that's a negative 2x. And then I have 7 plus 0 because there's no constants over there, so that gives me 7. So I now have our answer written in standard form, so we should be good to go. Be careful on this next one. There's an understood 1 here, which when you distribute that to get rid of parentheses, nothing really happens. So I have this going on. But then over here, whenever you subtract, you need to distribute that negative 1, and it's going to change all signs. So it's going to give you the opposite of every single term all the way across. Now I'm going to gather up my like terms. So when I do my x cubes, I have 9 of them, and negative 2 of them makes 7. X squareds, I have a negative 6 and a negative 1, which is going to give me negative 7. I don't have any x's to worry about, but I do have a positive 3 and a negative 2, which is going to be a positive 1. So be really careful. The SAT loves the subtraction of polynomials and getting people forgetting that distributing part. All right, we need to graph these. We need to describe the graph, increasing and decreasing from left to right, identify the number of real zeros. These can be kind of tougher to see, so I graphed them on my calculator. Then I also went and I got a table. So sometimes if the graph isn't showing you quite enough information, you could go to the table. And to me, I could tell that it crossed somewhere between negative 4 and negative 5, somewhere between negative 1 and negative 2. This point was on my table. And then there was another cross right here. And just kind of a rough sketch. It kind of came up. It went down, and then came back up. So describe the graph increasing and decreasing. So when you're going from left to right, so from here to here, this is an increase. All right, so we are increasing, then we decrease, then we finish with an increase. So that's describing it as increasing or decreasing. Identify the number of real zeros. Well, the real zeros are where you cross the x-axis. So this one had 3 real zeros. Boom. Excuse me. Number 6 was a little bit tough to see when I graphed, so I actually had to go to a table. And when I went to the table, I found that 0, 0 was the only spot. The other 0 was somewhere over in here. So we actually came down. We went up but didn't cross, just kind of nicked it, and then came back down again. So for this one, we only have zeros right there and right there. So we have 2 distinct, or different zeros. And actually, we say that there's a double root. We get further into this thing, we'll get a little more specific, but we have a double root there when it just kind of kisses or just touches the x-axis. But the table you either had to zoom in really close with your graph, or you had to kind of look at your table to determine were there any more zeros going on there. All right, next couple, find each product. So multiplying polynomials, pretty basic skill here. First thing is I'm just going to distribute. So this is going to be 8. And then the letters you just kind of smash together, x squared y. Plus, we're going to have a 14, x, and then y times y will give me y squared. Over here on this next one, this is a 2 by 2. So a times 3ab, well that's 3. A times a is going to give me a squared b. Then I distribute here. I'm going to get a b squared. So that's a different term, different family. One's a squared b's, the other's ab squareds. Then I do this one and I get 3 ab squareds. So that's matching. And then finally I get a b to the first times a b to the second, which would be b to the third. So there is like terms right here. I have 1 of those and 3 of those, so I can combine those. So my final answer, 3a squared b's plus 4 ab squareds plus ab cubed. All right. Now we have an expansion over here. We got a perfect square. 2x plus a third times itself. So I'm just going to kind of just write it out. 2x plus 1/3 times itself. This way you won't misapply a property or a rule and screw it up. Oftentimes, you don't want to do this, but oftentimes kids will square the first, they'll square the second, and then they miss the middle stuff. So I'll kind of show you what I mean. So if you square the first, you get 4x squared. And if you square the last two, 1/3 times 1/3, you're going to get 1/9. But there's some middle stuff going on here. You got to do 2x times a third. All right? So 2x times 1/3, if you just multiply straight across, you get 2x over 3, or 2/3 x, however you want to write it. And then you're going to get another one of those right here. You get a double. So you actually have 2 of those terms in the center. So 2/3 plus 2/3 is 1 1/3, or usually we'll just write that as 4/3. So I have 4/3 x's plus 1/9. That's how you'll probably see it. You could also write this term as 4x over 3, and it would not be wrong, but you may see it like this a little bit more often. Number 10 is a big dog. I mean, this is a 2 by 4, so you're going to have 8 pieces. I'm going to show you this one using a box. So I'm going to do a box with 2 rows for the first piece. Whoop, I don't know why I put the -3 up there. 2x minus 3. And then I have 4 terms going across. So I got to put 4 of those. I need an x cubed, a negative x squared, positive 3x, and a positive 5. And now we're just going to multiply every row by every column. So this is 2x to the 4th, negative 2x to the 3rd, positive 6x squared, positive 10x. Next row, negative 3 times x to the third, that's negative 3x to the third. And this is going to be a positive 3x squared. This is going to be a negative 9x and a negative 15. Now, not always, but oftentimes you can combine on the diagonals. So he's the only person in the x to the fourth family. I have a couple x to the thirds that can be combined. I have negative 5 of them. And then I have some x squareds. Those can be combined to make 9 of them positive. Then I have negative 9 and a positive 10, so this is a positive 1x. I think on the original answer key I screwed that up and I put negative x. And then the minus 15 is chilling by himself. And there we go. So it's kind of a nice way to organize it as opposed to, and you could still do this, but some people just get bogged down by all those arrows and they like the table better. So whatever floats your boat. Scrolling on down, expand using Pascal's triangle. So first thing is I want to create Pascal's triangle. And it has a lot of applications in statistics and permutations, combinations, that kind of stuff. So I got 1, 1, 1, 1. Now I just add every two numbers above me and put the sum right below. You always start with 1, end with 1. So that'd be 1, 3, 3, 1, 1, 4, 6, 4, 1. And I can keep on going as long as I want. But what I do is I use this power. This is a fourth power. So I need to use this fourth row right here. And all Pascal triangle does is it speeds this up to where I can use those coefficients. So I'm going to write down 1, 4, 6, 4, and 1. And then here's how the game is played. So you kind of have two pieces in that binomial. So another word for this, if you wanted to Google it and maybe see somebody else solve this, this is called binomial. Binomial because there's two pieces here. And then expansion because I'm expanding it out. So the first part of the binomial is x. So how that game is played is you start off with x to this power, x to the fourth power, and then you keep decreasing by 1. So x to the third, x squared, x to the first, and then there's no x's on the last one, so you just leave it off. You could write x to the 0, but it's just going to be a 1. Now I look at the second piece, that negative 3, and I do the exact opposite. So I'm going to have negative 3 to the 0, which is not going to be anything. Then I'm going to have negative 3 to the first, negative 3 to the second, negative 3 to the third, and then finally, negative 3 to the fourth. Finally, I get all of them. So basically, your first term starts at 4 and counts backwards to nothing. And then your second term starts at nothing and builds its way up to 4. And now I got to go through and I got to clean this up. So 1x to the fourth. Well, over here, a negative 3 to the first power, that's just negative 3 times 4 times x to the third. So that's a negative 12 x to the third. Negative 3 squared, I'm doing my exponents first, that's 9. And then I got to multiply, so that's 54x squared. Negative 3 times negative 3 times negative 3 is a negative 27 times 4 times x. So that's minus 108x. And then negative 3 times itself 4 times is a positive 81. So there is your final answer. Now, you could expand this by hand. You know, you could just multiply x minus 3 times itself 4 times. The issue is there's a lot of chances to make an error, and it's going to take a lot of room up. When you get better with expansion, it will be faster. Maybe not in the very beginning, but it is a nice little shortcut to have in your toolbox. All right, number 12. This one is to the third power. So the third row goes 1, 3, 3, 1. So 1, 3, 3, 1. And let's kind of apply our rule. So this x is going to start us off. And I start big and go small. X to the third, x squared, x to the first, and then no x's in the last one. Now this positive 2y, that's going to start with nothing and build its way up. So I got none of them here. Then I got 2y to the first. Be careful you use parentheses on this one. 2y to the second, and then 2y to the third. Now we clean this up, tighten up everything. I'm going to have x to the third plus, well, this is just 2y times 3 times x squared. So that's going to be a 6 x squared y. 2y squared, 2y times 2y is 4y times 3 times x. So that's 12xy. There's a squared there. And then the last one, 2y times 2y times 2y, that's 8y to the third. Final answer, boom. All right, moving right along, what do we got here? Find a polynomial expression in terms of x that represents the volume of a prism. All right, so volume of a prism. Well, first of all, I need to know the formula. Volume of any prism is just length times width times height. So over here, I'm going to just call this the length. I'm going to call this the width. And I'm going to call this the height. So we got to multiply those three things together. So it's just a word problem with multiplying polynomials. So length, so volume in terms of x is length times width times height. Now, since you have three numbers, you're multiplying three things together. Multiply says you can do whatever order you want. So you could multiply the first two, the last two, the first and the third. I'm just going to do it straight up as it is from left to right. So right now I'm just going to focus on these two. I'm going to ignore that last piece. So that's just going to be 3x squared minus 12x. All right, so I multiplied the first two together. Now I need to multiply it by that back number. And I'm going to crank this out. So this is, I'm going to kind of use FOIL or double distribution. So 2x squared, or 3x squared times 2x is 6x cubed. 3x squared times 1, well, that's 3x squared. And I move to the negative 12. Negative 12 times a positive 2, that's a negative 24. X times x is x squared. And negative 12x times positive 1, negative 12x. And then I clean this up, combine like terms in the center there. Positive 3, negative 24, that's a negative 21. Boom. There's an expression that will represent the volume. For any x that I slap in there, I should be able to get the answer out of it. All right, let's see what we got next here. Now we're going to be doing some division. So dividing polynomials, another kind of basic skill for the SAT. Well, I have a trinomial, a three-piecer, divided by a binomial, but I have a coefficient here. So for me, whenever that coefficient is not 1, all right, so if the coefficient is not equal to 1, then I'm going to do long division. All right, and I just kind of want to show you both ways anyway. So I'm going to do long division. 2y take away 1 goes into 6y squared, it's kind of crazy y, 13y minus 8. And here's kind of how long division goes. I need to see how many times 2y can go into 6y squared. Or what do I multiply 2y by to get 6y squared? And I multiply it by 3y. Well, once I get that, I need to multiply coming backwards. So I now need to multiply coming backwards and stack it up down below. So 3y times 2y is 6y squared minus 3y. And then with long division, you always subtract. So 6y squared minus 6y squared, and that's gone. That's nothing. Now I got to be careful here. Positive 13, take away a negative. Well, take away a negative means plus. So it's really 13 plus 3. A lot of people had 10 there, so be careful. 16y, I slide the minus 8 down. Just kind of drops down there. Now I play the game again. 2y goes into 16y positive 8 times. Now I multiply coming backwards. And 8 times 2y is 16y. 8 times a negative 1 is a negative 8. And now I have the exact same expression subtract itself. Gives me a remainder of 0. Now what that means is that's telling me 2y minus 1 is a factor. But I just need to divide it. So my final answer is this right here. This expression divided by this expression gives me that answer. And the way division always works is I should be able to go backwards. Kind of think about just numbers. If I said, hey, 10 divided by 2 equals 5, well, you should be able to check yourself and work backwards and say, is 5 times 2 equal to 10? Like, you should be able to go back both directions. And so if you did that and you weren't sure, you could multiply those two expressions together and see what you get. But I'm pretty sure I did this one right. All right, next problem. I could do long division, but I'm going to show you a shortcut called synthetic division. And how synthetic division works is we just use the coefficients. So I'm just going to use the 3, the 11 from the x squared, the 11 from the x, and the 15 as a constant. Be sure that all letters are accounted for. If you are missing one of those x squareds or x's, you need to put a 0 as a place value. So be careful. Now here's the tough part to remember is if you're dividing by x plus 3, we're actually going to use negative 3 for our synthetic division. So I'm going to use a negative 3 over here, and I'm going to put that out in that little right angle box there. It's basically when is x plus 3 equal to 0. So here's how the game is played. I basically, first of all, just drop this 3 all the way down. That gets me started. Now I multiply. So multiply negative 3 times 3, I get a negative 9. And now I'm going to add those two together to get 2. Now I'm going to multiply negative 3 times positive 2, gives me a negative 6. Add the column. Multiply negative 3 times 5, it's negative 15. Add the column, and I get 0. So that's my remainder. So luckily this went in there evenly. And my answer is going to be, it always starts 1 less than what our original number was. So this was x to the third. So I know that my final answer is going to be 3x squared positive 2x positive 5. And there is the answer. Now, if there was a remainder, let's just pretend that when we added up these last two columns here, let's just pretend, kind of fantasy world here, pretend that we got a positive 2. Well, what you would do in that case, if that was the scenario, you'd write your answer as 3x squared plus 2x plus 5 plus, you'd put the 2 on top of what you divided by. All right? So you're going to always put your remainder up there on top of that piece. But that was just pretend if the 2 happened, but that didn't really happen. This was really a 0. So don't want to confuse you. All right, use synthetic substitution. So this is kind of a spin-off that says, hey, we can use the remainder theorem. So this is kind of and this, I do see this on the SAT occasionally, but the remainder theorem says that if you do synthetic division and you get a remainder, that remainder is the answer when you evaluate the function for a number. So like if I said, hey, find the value, or if I said evaluate p of x if x equals -1, or basically, you know, we did functions earlier this year, I could just say, hey, find p of -1, which basically means plug -1 in there. Well, you could plug -1 in there, and in this expression it's not too complicated, but you can also do synthetic division and run it through, so 1, 2, -5, 6. And you could run it through there really fast and get add, multiply, add, and I get a remainder of 12. All right? And whatever that remainder is, that means that -1, when you plug it into the equation, you actually get the answer of 12. So it's a way to evaluate a function using the remainder from synthetic division. And you could verify that. You know, you could put the -1 in up above and see what shakes out. I'll just do this to verify it really quick. -1 to the 3rd power plus 2 times -1 squared minus 5 times -1 plus 6. And that'd be -1 plus 2 plus 6 plus 6. Let me just be careful. Make sure I didn't screw something up here. So that looks like it's 13. So what did I do wrong? Let me just double check my work. Should get 12. Oh, arithmetic error. -5 times -1 isn't 6. It's 5. And that'll give me my answer of 12. I was getting a little bit nervous there. Thought I disproved the remainder theorem. All right, let's try it again. So I'm going to do this one. I'm going to plug 2 in there. So use 2 for synthetic division. 1. Notice that we're missing the x to the 3rd. There is no x to the 3rd, so I have to put a 0 there. Then 1 for the x squared, 1 for the x, -6. Let's run it. Slide, multiply, add, multiply, add, multiply, add, multiply, add. So it looks like P of 2 gives me an answer of 16. And again, you could plug in there 2 to the 4th plus 2 squared plus 2, take away 6, and hopefully we get the right answer. So 2 to the 4th is 16 plus 2 squared plus 2 minus 6. 22 take away 6 is 16. So bam, checks out. Nice. Factor each expression. So factoring we did a little bit with quadratics. It's a tad bit different with polynomials, but some of it's similar. So first thing is I pull out a GCF. I see I can yank a 3 out of everybody. I can also yank a t out of everybody because he's got a t to give. So reverse distribution, 3t times t squared will give me my first term. -7t will give me my second term. -4 will give me my third term. So what I've done is I found 2 things that can multiply together to make that initial expression. Sometimes you can factor this piece, but I can't think of 2 numbers that times together to make -4 and add together to make -7. So I believe I'm done on this one. Sometimes you would go further. Well, this one to me looks like the difference of 2 perfect squares. All right, because I see 16y squared and the 49, those are both perfect squares. So what happens with difference of squares is one's a positive and one's a negative. That's the only way for that middle term to disappear. Well, I just take the square root of both of them. So the square root of this part is 4y, and that's going to go in the front. So that'll give me my 16y squared. I take the square root of this piece, which is 7, and that goes at the back. And that looks like it's going to check out. And there's nothing else I can do, no GCFs or anything to pull out. So I believe we're all done there. Number 20, whenever I see 4 pieces, I'm going to use grouping to factor this. So when I use grouping, I'm going to put parentheses around the first 2 terms, put it around the second 2 terms. Usually I'm going to pull out a greatest common factor that's different from both chunks. And then I should get a common piece in there, a common factor. So let's see what's going on. In the first piece, I can pull out, the biggest thing I can yank out is a y squared. And I get y plus 7. All right, so there's chunk number 1. Chunk number 2, the only thing I think I can yank out of there is a 2. And then I'll get y plus 7. And this is exactly what I want to have happen. You see how I have this common y plus 7 in both chunks. So if I have that y plus 7 in both pieces, I can factor that out. And then I can multiply that by the other 2 just put together. So I've now factored this thing into 2 binomials that if we did multiply them together, they would come back and they would multiply together to make that. Sometimes you have to pull out a negative right here in order to make your 2 parentheses work. So if you run into a problem where you're not getting that common factor, maybe try yanking a negative number out, and it may help you. All right, number 21. This one is the sum of cubes. So this tells me it's the sum, and these are cubes, cube roots. So the sum of cubes, we had a little cheat sheet in our notes that said whenever you do a plus b, or a cubed plus b cubed, if you want to factor that, it's always going to factor into a plus b, and then it's going to be a squared and b squared. And then the part that I always just got to keep track of is that if it's the sum of the cubes, it's going to be minus for this middle term. And the exact, everything's going to be identical, okay, except for if you do the subtraction of 2 cubes, there's going to be a subtraction here. Those are going to match up, but it's going to be different right there. All right? So just kind of keep that in mind. You'll be able to use a cheat sheet that can help you out. So the first thing is I want to rewrite this as 2 cubes. So I want it to be in the form something cubed plus something cubed. So I can rewrite a to the 6th. A to the 6th can be written as a cube. Well, how could I rewrite as a cube? Well, I could use a squared to the 3rd power. So this is going to be a squared cubed plus, well, 125 is just 5 cubed. So really how I'm viewing this is, to keep the pattern going, this right here is my A, and this right here is my B. So let's try to keep the pattern going. So it's just whatever A plus B is, all right, sorry about that. So I'm going to keep the pattern going. So instead of doing A plus B, this is now my A. So I'm going to have A squared plus B. All right, because remember, you're my A, you're my B, and then I got to follow the pattern in the back part. Well, I need A squared. So A squared is A. There's my A, and I got to square it now. So that's A to the 4th. Then I got to subtract A times B. So A times B, which would just be 5A squared. And then I got to do B squared, which is 5 squared, which is 25. And there we go. That should multiply out to make our original piece right there. So it's a little bit tricky. You just need some reps with it, and it shouldn't be too bad for you. All right, number 22 should say the volume of a box. I don't know why it says volume of a boy. The volume of a box is modeled by that function. Identify the values for x where the volume is 0, and then use the graph to factor it. So I want to break this down into 2 or 3 pieces that multiply together to make it. But first of all, where does it look like it's 0? Well, for sure it looks like we have a 0 at x equals negative, let me see, it goes by 2s, 2, 4. Then it kind of looks like we have one right here at negative 1. I'm not quite as confident about that one because it kind of just crosses somewhere. And then it looks like we have a 3. I'm guessing. Well, if I have zeros, those translate into factors for me, all right? Because factors are going to be opposites. So if x minus 4 is a 0, that tells me that x plus 4 is a factor. So if x plus 4 is a factor, let's do synthetic division and let's see what we get. And that'll help me get the next piece. So I'm going to go negative 4. And I have 1, 2, negative 11, negative 12. 1, 2, negative 11, negative 12. Bring the 1 down, multiply, add, multiply, add, multiply, add. Sweet, I got a remainder of 0. So that means that I now have x squared minus 2x minus 3. All right? So this is like another piece. So right now, I know that this times this gives me the volume. But I think I can break this down even further. I think I can factor this out because I can find 2 numbers that multiply together to make negative 3, but add to make negative 2. Right there is a good combination. So it looks like I have all 3 factors. I have my x plus 4 that I got from this came from the graph. And then these other 2 came from doing my division, but they were kind of what I suspected. You know, it looks like it was verified that we did cross a 0 at negative 1, and we did cross a 0 at positive 3, which will give me a factor of negative 3. So zeros do give you factors. A table could also verify that. All right, last one, number 23. A box without a lid can be formed by taking a 12 by 16 piece of cardboard and cutting a square with dimension x. So I'm going to draw that kind of up here. All right, so we have a 12 by 16 piece of cardboard. We're going to cut out this x by x on each corner. And cut that out. So I should be able to now fold this box up. And we should be able to have something like this. And the part that we fold up, this is going to be x tall. All right, because that's what I'm folding up there is the x. Well, but now my width and my length changed because it was 12, but I need to take away this x, and I need to take away that x. So really I have 12 minus the 2 x's over here on the side. And then when I fold this box up, you know, on this piece, this is going to be the edge of the box, which is going to be 16 minus 2x. So now I should be able to get the volume. All right, the volume in terms of x is just length times width times height. All right, and I'm going to do this in order. I'm going to just do the first two. So that's 160 plus another 32, so that's 192. And that's minus 32x. There's minus 24x. And then a positive 4x squared. Let's clean that up while we're here. And I'm going to put the 4x squared in the front just because I like it. Standard form. I got a 4x squared. Slap my x's together. I get a negative 56x. And then I get a constant of 192. Now, don't forget, though, we've only just done this part. So I still have to multiply by this little old x over here. So I could put it at the back, I could put it at the front. I'm going to put it at the front so it looks a little more traditional. And now we just multiply, and I'm going to get 4x cubed minus 56x squared plus 192x. So there's the volume written in terms of x. Then use the expression to find the volume when x equals 2 inches. So it says I got to use this expression when x equals 2. So 4 times 2 to the third minus 56 times 2 squared plus 192 times 2. Well, 4 times 2 to the third, that's 4 times 8. That will be 32. Then we have a subtraction. 2 times 2 is 4. 4 56s is 112, 124, negative. And then 192 doubled is 384. And let's slap that together. So I don't know, I'll put my positive. I'm doing this in my head, so I'm going to kind of combine it kind of weird. 32 plus the 84, that's going to be 416. And I got 416 and a negative 124, so that's 316. Is that 292, I believe? Positive 292. Double check my answer here, make sure I didn't screw up. 192. All right, what did I do wrong here somewhere? I don't know, maybe my answer key's wrong. Let me just double check something though. If I just go back and if I just call x as 2 inches, and I'm like, all right, taking away 2 and I'm taking away 2, that means I'm taking away 4. So this side is really 8. And if I take away 4 from the other side, this is going to be 12. And if this is too tall, so I'm really going to have 12 times 8 times 2, which is 96 times 2, which should be 192. So how am I getting 292 here? What went goofy? Oh, right here. 2 times 2 is 4 times 56. 4 56s is 224. 224, which is going to be 192. Always got to go back and figure out what my mistakes are. And I like to not edit this out because this is what happens for real. You know, if I'm on a test, I do it using algebra. Then I go back and I just run it with the real numbers and make sure they jive. And if they don't, I got to go back and figure out what went wrong. All right, hopefully this gets you ready for the quiz. If you got any questions, ask me. See you.